Hi, in this video we'll be going over friction in physics. We'll start off by doing a quick introduction to friction, where we'll compare static and kinetic friction. We'll then go over different equations we're expected to know to solve friction problems. We'll then look at two general types of friction problems. We'll end this video off with a more complicated type of problem involving friction. Friction can be defined as the resistance one object feels when moving over another. A way to visualize this is if you look at this zoomed in diagram of the box and the plane. The box has a textured bottom, and so does the plane it sits on. And what happens is these bumps and grooves interlock, which makes it harder for the box to move, and this is what causes the force of friction. Now, there are two different types of friction. There's static friction and there's kinetic friction. Static friction is the friction we need to overcome when we first apply the force. If the object is completely stationary on a plane, these bumps and grooves interlock a lot more than if the box is already in motion. This makes it such that there's more friction. In kinetic friction, the box is already in motion, so it sort of glides over this textured part, which makes it easier to move. Have you ever noticed when you push a heavy object or a box, it's always harder to get the box to move, but once it starts moving, it's a lot easier to keep it moving. This is because of friction. If we have a stationary box and we push it to the right, there are four main forces acting on the box. There is a force due to gravity pulling the box down. There's a normal force between the box and the plane, pushing the box up, keeping it from falling through. There's a force that we apply to get the box to move to the right, but at the same time, there's a force that kind of resists the force that we apply. This is the force of friction that is caused between the box and the plane. One more thing I want to note is the fact that static friction is almost always greater than kinetic friction. And again, this is due to the fact that in static friction, these grooves interlock a lot better than during kinetic friction. And that's because when the object is already in motion, the grooves kind of glide over the plane's grooves. So therefore, it takes less force to keep the box in motion. When it comes to Physics 1, there are a few equations that will be helpful to know for friction. These equations are listed here. So the normal force is equal to mg times cosine theta. If your object is on a plane that does not have an incline, then you don't have to worry about the cosine theta. However, if your object is on an incline, then the theta refers to the angle of incline. We will have another video where we go over how we derive this equation. But if your object is just on a plane, the normal force will be equal to the gravity force, but opposite in direction. So just mass times gravity. Next, you'll need to know how to find force. Force is just equal to mass times acceleration, and this is often the force that we apply. So if we want to move the object to the right, we're applying a force to the right, and that depends on the mass and the acceleration of the object. As we mentioned, force due to gravity, this is just 9.81, which is the acceleration due to gravity times the mass of the object. Also, remember, mass is always in kilograms. Lastly, we have the force due to friction. This is either static friction times normal force or kinetic friction times normal force. This will yield the force due to friction. We only get this if the object is in motion, and in that case, the force of friction will be opposite the direction of motion. So in this case, if the object is moving to the right, or if we're pushing the object to the right, the force of friction would be to the left. Or in this case, if the object is falling down the ramp, then the force of friction will be up the ramp. Let's take a look at this problem. So it says we push a 7 kilogram stationary box with 300 newtons of force to the right. Taking all forces into account, what would the magnitude and the direction of the net force be? We're also given the static friction and the kinetic friction. Now, this is a pretty standard type of friction problem in physics, so let's go over it. So a good place to start is to draw a force diagram and draw arrows signifying all the forces acting on the box. So we have a gravitational force pulling the box down. We have a normal force between the plane and the box. It mentions that we want to push the box to the right, so there's going to be a friction force to the left. Now let's fill out the values that we already know. So we already mentioned that we're gonna push the box with 300 newtons of force to the right, and we also know that the box is 7 kilograms. So what can we derive from this information? Well, we're given the mass, and we know that the acceleration due to gravity is 9.8. So we can actually find the gravitational force. But wait, we can also find the normal force, because since the box is just on a plane that is not on an incline, then the normal force is equal to the gravitational force, just the opposite direction. So as you can see, the gravitational and normal force is 68.6 newtons. Next, with all this information, we can try to find the friction force, because if you recall, friction force is either static friction times the normal force or the kinetic friction times the normal force. And since the box is stationary, we use the static friction. So we multiply the static friction by the normal force to get the force due to static friction when we push the box to the right. We get a value of 34.3 newtons. So the question's asking for the magnitude and the direction of the net force. So the gravitational force and the normal force actually cancel out. This is because they're the same magnitude, but on the opposite direction. However, the force pushing the box to the right, which is 300 newtons, and the force due to friction, which is 34.3 newtons, are not the same magnitude. Therefore, to find the total net force on the box, all we have to do is subtract 34.3 from the 300 newtons, and this gives us a force of 265.7 newtons to the right. Let's take a look at the next problem here. Now, this problem is very similar to the last problem, however, there's a slight difference. Now we're looking for the acceleration of the box after pushing it for a few moments with a constant force. So therefore, the force due to gravity will not change, as we haven't changed the mass of the object. At the same time, the normal force will not change, because again, we haven't changed the mass of the object, nor the incline of the plane. What will change, however, is the force of friction, because now we're looking at the force of friction after we've been pushing the box for a few moments already. So we're going to be using the kinetic friction. Therefore, instead of multiplying static friction by normal force, we're going to be multiplying kinetic friction by normal force. So 0.4 times 68.6 newtons, we get 27.44 newtons. So ultimately, we're looking for the acceleration of the box after pushing it for a few moments. To find acceleration, we need to find the total force acting on the object. Since we know that we're pushing the box with 300 newtons of force to the right, and we know that the kinetic friction that resists our push is 27.44, we know that the total force acting on the box would be 300 newtons minus 27.44 newtons, which equals 272.56 newtons to the right. Again, here we neglected the force due to gravity and the normal force because they basically cancel each other out. How do we find the acceleration? Well, now, since we know the total force acting on the box, we could just use F equals ma. We plug in the force, which is 272.56 newtons, set that equal to the mass of the box, which is 7 kilograms, times the acceleration. And then we just solve for acceleration, and in this case we get 38.94 meters per second squared. Now, this is not realistic whatsoever. However, this is the correct response for this question. Let's take a look at an incline problem. So this problem says a 5 kilogram box is held stationary on an incline of 30 degrees. If we push it uphill, how much force do we need to push with to get the box to move? We are given the static friction as well as the kinetic friction. So where do we start? So a good place to start is to draw the force diagrams. So we know that there's a gravitational force that pulls the box straight down. We also know that there's a normal force between the plane as well as the box. Notice, however, that the gravitational force and the normal force are not the same. This is due to the fact that the box is actually at an incline. We will be making a video going over the incline problems in more detail. We also have the arrow depicting the force we input to push the box upward. And again, this is countered by the friction. Now, if you plug in values we know and we solve for the gravitational force, we get 49 newtons. And again, this is just the mass of the box multiplied by the acceleration due to gravity, which is 9.8. This yields 49 newtons. The normal force, since we're at an incline, we're going to have to use the full equation, mg times cosine theta. So we need to take into account the incline. If we plug in the values for mg times cosine theta, we get a value of 42.44 newtons. Again, this is not the same as gravity because the box is on an incline. Now, if you notice here, I've actually drawn another force. This is the force of the box wanting to go downhill. Since the box is uphill, it wants to go down, and it's being held stationary. This is the equation we used. We'll worry about that in the incline problem video. So next we can find the force due to friction. This is simply the static friction multiplied by the normal force. This yields to 21.22 newtons, and it goes downhill. Now ultimately what we're looking for is how much force we need to put in to move the box uphill. And since we know that this force, the force of the box wanting to go downhill, plus the force of the friction, are two forces we need to overcome. So we need to, in total, have a force of greater than 69.63 newtons to be able to push the box uphill. This will allow us to overcome both the friction and the force pushing the box downhill. Now, to do a quick recap, these are some important equations that I feel like would be really beneficial to try to memorize. The normal force is equal to mg times cosine theta. You don't have to worry about cosine theta if the object is on a plane and doesn't have an incline. If it does have an incline, theta refers to the degree of incline. If we apply a force is equal to mass times acceleration. Force due to gravity is equal to 9.81 times mass. 9.81 is just the acceleration due to gravity. Force due to friction is equal to the static friction or kinetic friction times the normal force. You will often be given the static friction or kinetic friction. And lastly, force pushing something downhill is equal to mg times sine theta. I hope this video was helpful, and I hope you have a great rest of your day.